Hey guys, Mr. Sebastian here, and today we are going to work on the quotient rule. So, the quotient rule states to divide powers having the same base, you blank the exponents, and for that we are simply going to say we divide the exponents. Or no, not divide, sorry. When we divide, we subtract the exponents. Subtract. And our algebraic rule for that, where it says algebra, we're going to say that when we have a to the m over a to the n, that is the same as a to the m minus n. So we simply just subtract. So if I go up here and look at some of these examples, I'll zoom in now. If I have 8 to the 10th over 8 to the 4th, that is the same as 8 to the 10 minus the 4th, or simply our answer would be 8 to the 6th is our answer. 8 to the 6th. Okay? So if I have negative 3 to the 9th over negative 3 to the 4th, it's simply enough, guys, your base just stays the same. And 9 minus 4 is 5. And just subtract those exponents. On this one, if you notice, we have a multiplication going up in our numerator, so let's solve that first. And remember, when we multiply bases, we just add the exponents. When we multiply bases that are the same, we add the exponents. And that's because we say a to the m times a to the n equals a to the m plus n. So this is going to be the same as 5 to the 12th all over 5 to the 7th. And now that we have it simplified, we can keep the base the same and just subtract our exponents. We're going to do 12 minus 7 is 5. 5 to the 5th, not 5 to the 7th. 5 to the 5th. And that's our answer. We just subtract the exponents. On this one, we have 1 over y to the 5th times y to the 8th. Remember, that's the same as y to the 8th over 1. So we can just multiply across. We're left with y to the 8th over y to the 5th. And we keep our base the same, and we just subtract the exponents when we subtract. Or when we divide, we subtract. So an example would be something like, I don't know, we can say 13 to the 17th power over 13 to the 5th power would be the same as 13 to 17 minus 5, which would give us our final answer of 13 to the 12th power. So that's how you solve that problem right there. So that is the quotient rule. Now this next rule is pretty self-explanatory. We've kind of talked about it already. It's kind of like the distributive property, where it just simply says that if I have multiple things with an exponent on the outside of parentheses, that everything inside the parentheses gets that exponent. So this is just x to the 7th over y to the 7th. It just says it's kind of like the distributive property. We just give everything on the inside that. So this would be negative 7 times negative 7 would be a positive 49, and x times x would be x squared. So that's our answer there. So you just kind of distribute that exponent to everything on the inside. If we look at our notes over here in algebra, we can just say that if I have a over b all to the mth power, that's the same as a to the m over b to the m. Same exact answer. And once again, if I make one up, let's say we have 2/3 to the 7th, I just give both my numerator and my denominator that exponent. And that's all that says there. Okay. Hopefully so far so good. Let's look at some more examples. I'm going to zoom in again. So if I have 10 to the 6th over 10 to the 2nd, that's simply just going to be 10 to the 4th. You just subtract. 9 to the 210th over 9 to the 207th is just, 210 minus 207, just 9 to the 3rd. 4 to the 17th over 4 to the 14th, which would be 4 to the 3rd. 6 to the 8th over 6 to the 3rd would be your base stays the same. And I haven't mentioned this yet, the bases have to be the same. If I have something like 4 to the third over 3 to the second. My answer is 4 to the third over 3 to the second. This quotient rule only applies when our bases are the same. If our bases are not the same, the rule does not apply. Back to this be 6 to the fifth. I really don't like these problems down here. They're not the most applicable. I'm going to show you how to do it real quick. Remember when we have the quotient rule of a to the m over a to the n, that's just the same as a to the m minus the n. So my base stays the same, and I just have y plus 1 minus y. Because I just take my exponent in the numerator and I subtract it from the exponent in the denominator, so I'm left with just 2 to the 1 power, because my two y's will cancel each other out because I have y minus y. Same thing here, I'd have 8y plus 3 minus my denominator exponent, which is 3, which would leave me with just 8 to the, that's not the y, that's a y there, 8 to the third. I am not very worried about 5 and 6 guys. I put it on there because your textbook had it in a couple places, but mainly if you can remember, just subtract the exponents, you're good there. Let's try a few more of these, and I think we'll be good. So if I have xy to the 6th, remember I just distribute that exponent to everything. So that's x to the 6th, y to the 6th. That's it. On this one, a lot of kids on Monday's homework kind of forgot about this. I have to apply this exponent right here to everything in my problem. Everything. So 5 squared is 25. C to the second is c to the second. And be d. And we're with a power to power. If I have a to the m to the n, that equals a to the m times n, so that would be d to the fourth. Okay. On this one, I apply the 3 to everything. So 4 to the third power would be 64. D to the third would be d to the ninth, because I multiply my bases there, or multiply my exponents when I have a power to a power, and that'd be c to the 15th. On this one, 3 to the third would be 27. W to the third would be w to the third, all over g to the 18th, because I multiply my exponents together there. Let's find something that's a little bit different. Well, I guess here, if I have -2 to the second power, that'd be a positive 4. D to the 11th to the second, I multiply those, get d to the 22nd. F to the 6th to the second, I multiply to get f to the 12th. And that's all over c to the 36. Okay, here, let's do, I'm going to skip this one just for now because it has something we haven't talked about yet. Let's do this one right here. This is a great one. So on this one, I would be careful before I do anything here. I am going to simplify what's inside my parentheses. So I'm not going to take 24 to the third or 8 to the third or my t's yet. I'm going to simplify what's in my parentheses first. And the first thing I see in my parentheses is that I can just divide. Just like if I can divide normally, I'm going to divide here too. And -24 divided by 8 would leave me with -3. And t to the 6th over t to the third, well, I'm going to subtract those and be left with t to the third, but all that to the third power still. So I'm going to, whenever I have a chance to, I want to simplify inside my parentheses first. I want to simplify inside my parentheses first. Once I'm done here, then I can apply that exponent on the outside. Kind of like PEMDAS, guys. We do parentheses first. So that's me leave me with a -27, because 3 times 3 times 3, or -3 times -3 times -3 t to the 9th. Because don't forget, you treat your coefficients. These get treated normally, so that's a normal 3 to the 3rd. But with my exponents, I just multiply 3 times 3 to get 9. On this one, before I touch anything on the outside, I'm going to simplify on the inside, and I'm going to have d to the 11th over d to the 11th over d to the 6th, which will leave me d to the 5th. F to the 16th over f to the 6th will leave me f to the 10th. All of that to the 2nd, and that means my final answer would be d to the 10th, f to the 20th. Let's do a couple more. Let's do 18 right here. Remember, with my coefficients, I treat those normally. So that says 21 divided by 7, so that's going to be 3. Then with my exponents of my variables, I am just going to subtract. So it'd be d to the 7th, and that's going to be e to the 2nd. So treat your coefficients normally, and treat your exponents with the exponent laws. And let's do one more right here. Last but not least, if I have a negative 16 over a negative 4, that leaves me with a positive 4 when I divide. And I have w to the 7th over w, so it'd be w to the 6th. And I have r to the 2nd r over r, so it should be r, because remember these have an exponent of 1 even if you don't see it. Okay, guys, I'm trying to see if there's anything else I want to do with you real quick. Let's do one more. Let's do... Actually, we can call it quits there. I think that's enough.